Welcome to Lesson 8.1 Notes, Monomials and Factoring. In Chapter 7, we multiplied polynomials. This time we're going to factor them. So we'll start with the end of what we got in Chapter 7, and we will get the beginning. So it's kind of like we're working backwards. Our past target, we identified monomials, multiplied monomials, and divided monomials. We've done all three of those things. Okay, today in these notes we're going to talk about factoring monomials and finding the greatest common factor of monomials. And then in the future chapters, I can get my pen to write, there we go, we will factor polynomials. Okay, so let's go ahead and get started in our notes. A monomial is in factored form. Notice that is in bold for us. When it is expressed as the product of, and here's what we need to put in there, prime numbers and variables. Okay, so prime, hopefully we remember what that means. We'll talk about that again in a minute. And no variable has an exponent greater than 1. Okay, so if you remember, a prime number is any number that is, its only factors, if I can get this to work, only factors are its number and 1. Okay, that's the only factors of a prime number. So we can't get any, like 6 is not a prime number because 2, 3, 1, and 6 are all factors of that. However, 2 is a prime number because 1 and 2 are the only factors. So we're going to jump right into example 1, and we're going to factor each monomial completely. And hopefully you remember how to do a factor tree. So A is really a review, and it's a connect to what we already know. So 84 is just a number, but we learned last chapter that is a monomial. So we're going to take 84 and we're going to break it up into 2 of its factors. Here's the great thing. It can be any 2 factors because the factor tree keeps going until you hit all the prime numbers. What I like to do when it's an even number like 84 is go ahead and divide by 2 because I know it can divide by 2. That's going to be one of my prime factors, and I list that first. If I don't know what this is divided by 2, I can use my calculator to help me, but hopefully we can do 8 divided by 2, 4 divided by 2, and we get 42. Now obviously 2 is now a prime factor, so I'm going to go ahead and circle that because it's done. That branch is done. Now I look at 42. Well, it also is a even number, so it's divisible by 2. And so I'm going to put 2 down as one of my factors, and it's prime, and then whatever's left, so 21. So 2 times 21 will give me 42. Well, 21 is not even. However, I do know that 3 goes into it. I usually try to go up my number, so 3 is the next prime number. So I'm going to put 3 times 7, because those are the factors there. So, well, 3 is a prime number, as is 7. So when I factor this completely, 84 factored completely is 2 times 2 times 3 times 7. And that's as easy as that is. So there's my number broken down into prime number factors. So when I look at B, B is different because now we are dealing with variables as well. But those are pretty easy to add on to the skill we already know. So the first thing I'm going to do is break 18 into its prime factors. So again, it's even, so I'm going to do 2, and that will be 9. So 2 is a prime factor. 9 can be broken into 3 and 3. If it wants to write. Okay, let's see if I can write it down a little bit further. So 3 and 3. So that is now broken down into prime factors. So 2 times 3 times 3. And then to break x to the third up, remember, an exponent tells us how many of those x's are being multiplied by themselves. So it's just times x times x times x. So that's the 3 x's. And then how many y's does it tell us are there? 2 y's are being multiplied as well. So now we have a prime factorization of this monomial because none of our exponents has a number greater than 1. These are all 1 if I put them in here. And then these numbers here are all prime numbers. Okay, so let's look at C. This is another example. So I'm looking at 51, and some of you may be thinking, well, 51 is a prime number. Always double check. Now it's not even, so 2 does not go into it. However, 3 will. So if I put 3 down and plug it into my calculator, if I don't already know, it is 3 and 17. And this is 51 is a number they like to trick you with a lot. That's why you'll see it a lot, and you'll know after a while that 51 is 3 times 17. And now 3 and 17 are both prime numbers. So now it's ready to be listed. So we get 3 times 17 times, and then how many m's do we have being multiplied? 5. So I have to put 5 m's down. 1, 2, 3, 4, 5. And then we have 1 n. So there we go. And then 3 p's. 1, 2, 3. Okay, and that's it. That is this right here is the prime factorization of that monomial. Now let's look at D. You should notice there's something a little different about D, and that is that it starts with a negative number. So we have to take care of that negative first. Otherwise, it's going to mess us up in all of our factoring. And the very first thing you do whenever you have a negative number and we start factoring with a tree is we take out a negative 1. So now we have negative 1 times 144, okay? And that is going to be a factor of itself. Negative 1 is its own factor when we're talking about breaking a monomial into its pieces, into its factors. Now 144 looks like all the other ones we've done, and this one is even, so what do you think is going to be our first factor? 2. And then this will be 72. So, and 72 obviously is not a prime factor, so but it is even still, so I'm going to do 2, and this will be 36, right? And then 36 divided by 2 is 18. 18 divided by 2 is 9. And then 9, I need a little more space here, divided by 2 is 3 and 3. Okay, so now we have all of our numbers. There's quite a few here. 144 is pretty big. So it's going to be negative 1 times 2 times 2 times 2 times 2 times 3 times 3. Let me make sure I got those right. So I have a negative 1, 4 2's, and 2 3's. Okay, so then I have to break up my variables. So times A, oh, there's times in there, times C 4 times, C, and then that is your prime factorization of that number. And that's it. That's all we're doing in this first part, because we have to be able to do this to get to our next part. Okay, so let's see here. Oh, what happened? Okay, so hopefully you can all see that. So that's our factor tree went all the way down up here. Okay, so let's go to our next page. I'm not sure. Here's a quick brain break. All right, hopefully that gave you a quick laugh. Now let's go on to our next part. So the greatest common factor is the greatest number that is a factor of both original numbers. Okay, so if 2 or more integers or monomials have no common prime factors, their GCF is 1. That's it. Okay, because that's the only thing that'll go into both of them. And the integers or monomials are said to be relatively prime, meaning if I compare those two to each other, they are prime numbers, okay, just because I can't get a common factor. So what we're going to do is combine what we're doing here and looking at A. So I have 108xy cubed and then 126x squared y squared. So we're going to look at what factors they have in common. So the first thing we have to do is do our tree. So I get 2 and 54. I get 2 and 27. And then 3 and 9. And then 9 can be 3 and 3. Okay. So we've got both of those going. So that's my numbers. And then when I look at 126, let's do this over here just so I have more room. This is also even. So I get 2 and 63. 63 is 7 and 9. 9 goes down into 3 and 3. Okay. So that's the harder part, is breaking up my number. Let's go ahead and pull this up so we can write the rest of this. I'm going to rewrite down here 108xy cubed, and we're going to write out all of our factors. So I get 2 times 2 times 3 times 3 times 3, and then times x times y times y times y. Okay? Then we're going to do the same thing with 126 x squared y squared, and so that's going to be 2 times 3 times 3 times 7. And notice I put them in numerical order, and you'll see why we do that in just a minute. But I don't want to put them just, in any order, even though I can find them in any order. So notice the 2, and then I found the 7 and the 3 and the 3. But when I list them, I always want to list them numerically. And then I have times x times y times y. So now what I'm going to do is look for the prime factors that they have in common. So they each have at least 1, 2, right? So there's 1 in common. Then they both also have a 3. They both also have another 3. Okay? There's no more numbers in common, no more prime numbers, but they both have an x, and they both have a y here, and they have another one. So do you see how I was able to circle things they have in common? So then the GCF is going to be the multiplication of all these things together. So it's the GCF equals 2 times 3 times 3 times x times y, which is 2 times 3 is 6, times 3 is 18, so 18xy squared. And so that is the GCF for these two monomials up here. Okay? And yes, it seems like it took a while, but these are our notes. Remember, we always kind of do everything the longer way so we can see how we get there, and some of you will see a quicker way as we go. For your purposes, I want you to do B on your own. You try. You have this one to look at. The only difference is you now have 3. So when you're down into the circling part, it has to be in all 3 for you to be able to circle it. 2 of them can have it, but if the third one doesn't, it is not a common factor for all 3. So see if you can come in to class with that done. Then we have our real world example. If you have this done, when you come in, and here's what I would do. I would make a box, the rectangle, because Ms. Baxter wants to tile a wall to serve as a splash guard above a sink in the basement. She plans to use equal-sized tiles to cover an area that measure 48 by 36 inches. What's the maximum size square tile she can use and not have to cut any of the tiles? So it's always good to kind of have a picture in your mind of what's going on. Think about it. She wants equal-sized tiles so she doesn't have to cut any. So what do they have to be? Okay, that's what you're finding. And think about what we just did, and that will probably be used in this problem to find your solution. And then B, how many tiles of this size will she need? Okay, so that should be enough for your 8-1 notes. We will continue and do additional practice in class.